We're talking special right triangles. Now, what's special about them is the fact that we're going to produce shortcuts in order to find missing pieces. Remember, you always have Pythagorean's theorem to work on to find things, but you have to know two of the three pieces for Pythagorean's theorem. So let's look here for a second. If I gave you a right triangle and I said this side and this side were congruent, and I said the hypotenuse is 5. First of all, what type of triangle is this? I know it's right triangle, classified by sides. I have two congruent sides, so this would be an isosceles. Okay, so I'm asking you to find the length of these sides. Well, I'm going to label this x, label this x. We can use Pythagorean's theorem to figure this out. So let's look at it for a second. That would be x squared plus x squared equals 5 squared. A squared plus b squared being your legs, oops, equals c squared. Okay, so combine like terms. 2x squared equals 25. Alright, then what do we got to do? Divide by 2. Divide by 2. X squared equals 25 over 2. Before you go to a decimal, please don't. We're going to want a lot of these in simplest radical form, so we're going to have to review how to do a number of these things. So I don't have x yet. Without going to a decimal, I'm going to square root both sides. Now, you recall, you put this in, you got a positive and negative, algebraically speaking, but you're finding the length of the side. Will the negative be an option? Answer no. Okay, so right off the bat, we see this. Rules of mathematics. Can you have a fraction under the radical? No, you cannot. Let me focus this for a second. That looks better. Yeah. So now what do? Well, we break it down. A radical numerator, radical denominator. So right now that gives us what? Perfect square. Awesome. Again, rules of algebra. Can't have a radical denominator. So recall. It's been a while, I know. Recall. We got to rationalize this denominator. Make the next perfect square. I'm going to rephrase that so when you get into algebra 2, you can use it. Make the next perfect root. In this case, it'll be a square. So what do? To rationalize this denominator, I know the next perfect square will be 4. So we do this. Gives us 5 radical 2 over square root of 2 times the square root of 2. Some of you will say the square root of 4. Simplify. These 2's cannot cancel. Remember, not really a 2. Not really a 2. So our answer is this. Yes, it could be done in a decimal, but we want exactness, no rounding. So simplest radical form. We got to start remembering those things. Okay. So now let me ask you another question. Since this is isosceles, these sides are equal. What are the degrees going to be here and here? Give you a second. They are the base angles in your isosceles, so they have to be equal. So they're both going to be 45 degrees. All right. So now, let's look at a problem here. This time I'm going to give you another right triangle. It's got to be right triangle for these things to work. I'll give you 3, 3, and we got to find x. Okay, so I'm asking you to find the hypotenuse. So what is the first thing that come to mind? Well, Pythagorean's theorem. 3 squared plus 3 squared equals x squared. All right. 9 plus 9. Solve. X equals, it's not going to be the square root of 18. Remember, simplest radical form. There's a perfect square in there. 9 times 2. So your answer is going to be 3 radical 2. 3 radical 2. Remember, this isn't a 2. It's some decimal 1.4142 and so on. This is called the exact answer. No rounding occurred. All right, so now, the whole reason for doing all this stuff is we want to come up with a shortcut. This is called an isosceles right triangle. You'll hear me refer to them as a 45, 45, 90. In a 45, 45, 90 triangle, here's our relationship. The hypotenuse is equal to one leg times the square root of 2. One leg times the square root of 2. So go back to this problem right up here. Actually, let's do this one. It's equal to one leg times the square root of 2. So if I knew this, I did the work here, I did these steps. If I knew this, look what we can do. One leg is 3. They're both the same, so it doesn't matter which one you take. And take it times radical 2. 3 times radical 2 is that answer right there. All I got to know is it's a 45, 45, 90. 3 radical 2. Okay? So if I gave you a right triangle and had 5 and 5, find the hypotenuse. Well, take one leg times radical 2. Done. That's all you got to do. So now let's apply this for a second or two. All right? Let's see here. First one, another example I want to give you is this. Now, this only works when you got a 45, 45, 90, an isosceles right triangle. So let's say I give you this, 90 degrees there, 45 degrees there. Is this a 45, 45, 90, or is this an isosceles right triangle? The answer is yes. We know that. Okay. Let's say this is 6. You got to find the length of the sides. Use this to help you out now. You can go x squared plus x squared equals 6 squared and go through and do all these steps. You are more than welcome to do that, and if you're not seeing things, feel free to. Or apply this. Hypotenuse, 6. So plug it in. Do we know the leg? No, so call it x. Times what? Radical 2. Are you done? Not quite. Solve the problem. How do you get x by itself? Divide by the square root of 2. Alright, canceled. X. But now, can we leave this as it is? And the correct answer, as you are all screaming, is no. Make the next perfect root. Okay. Well, I know it's going to be a 4. So it's going to give us 6 radical 2. Square root of 2 times square root of 2 is 2. Outside the radical being multiplied, outside of a radical, you have to reduce just a little bit more and get an answer of 3 radical 2. Don't confuse that with this problem. Notice where x was located. All right, try one more if you would, please. This time I'll give you these markings, and I'll call this the square root of 21. All right, interesting dilemma we have here, but apply what you know. It is a hypotenuse, so radical 21 equals leg times radical 2. Okay? Divide by radical 2. Divide by radical 2. What's that give us? Cancel. Square root of 21 over the square root of 2. Square root of 21, square root of 2. Okay. Same deal. Got to make the next perfect root. What's that going to be? Common theme you're noticing here. Yeah, we're going to make it up to a 4. Now, this, recall, this being under radical, this being under radical allows you to multiply them together. So we get the square root of 42. Square root of 2 times square root of 2 is 2. There is your final answer. Isosceles right triangles, 45, 45, 90.